Ever been there? You know, machining a long, thin part on the CNC lathe, like an axle or something even trickier, maybe a rifle barrel,
Oh, yeah.
and it just feels, well, wobbly. You end up fighting chatter marks, the surface finish isn't great, maybe the dimensions are just off.
It's a super common headache.
Yeah.
Absolutely. Those longer workpieces, they just introduce stability problems.
Right.
And, the key often kind of overlooked is really getting to grips with the tailstock on that CNC lathe. Using it correctly, I mean.
Exactly. And that is precisely what we are diving into today.
Good stuff.
Our mission here is basically to shortcut the learning curve on the tailstock. How it works, how to adjust it.
Yeah, the essentials?
We've looked at a bunch of material function, alignment, pressure, centers, all that stuff, and we're going to boil it down.
Think of it like this. We want to give you the focused insights, the actionable stuff that actually helps you get better results on those tricky long parts.
Without getting bogged down in, overly technical jargon.
Right. Practical takeaways.
Okay, let's start at the beginning then. The tailstock. It sits there at the end of the lathe. What's its actual job? What's the fundamental role?
Okay, so its main purpose, really, is to support the free end of the workpiece, the end that's not held in the main spindle chuck.
Right, the floppy end?
Kind of, yeah.
Yeah.
Imagine trying to hold like a long metal rod really steady while pushing on its side. It's going to bend, isn't it?
Yeah, makes sense.
The tailstock acts like a second anchor point. It stops, or at least significantly reduces, that bending, that deflection, and the vibrations that come with it when you start cutting.
So it's basically pushing back against the cutting tool's force.
Yeah.
Providing stability.
Precisely. That stability is absolutely fundamental if you want to machine accurately along the whole length.
Uh-huh.
And sometimes you can even use it to hold certain tools, mostly for things like center drilling, before you start the main turning.
Gotcha. Yeah, you see pictures of it propping up a long shaft, and it just looks solid, like it's preventing that bend. So how does that support actually help the final part? Better accuracy, better finish?
Both. Absolutely. If you've ever pulled your hair out over, say, a slight taper on a shaft that should be straight.
Been there.
Or those awful chatter marks ruining a finish. Or maybe the part isn't perfectly round along its length.
Yeah.
Using the tailstock correctly is often the fix.
So it's not just nice to have, it actually directly improves the part quality.
Oh, significantly. By making the whole setup more rigid, it stops the workpiece flexing or vibrating so much under the tool pressure.
Okay.
And think about it, if the workpiece isn't moving around or bending, the cutting tool can do its job much more cleanly, much more consistently.
Right, that makes sense. So let's dig into that. How exactly does it stop things like taper?
Okay, taper. When your cutting tool pushes against a long workpiece with no support at the end, it naturally wants to bend away from the tool just a little bit. And that bending effect often gets worse the further you are from the chuck. That's where the taper comes from. The tailstock provides that solid anchor at the other end. It fights back against those cutting forces, keeps the workpiece straight.
So it resists the bend.
Exactly. And this becomes really critical when the part's length is, say, more than 2 or 3 times its diameter. Even tiny amounts of deflection there can cause major taper.
Wow, okay. So for those long, skinny parts, it's basically non-negotiable if you want accuracy. What about chatter, those vibrations?
That's the other huge win.
Yeah.
A workpiece held securely at both ends is just way less likely to vibrate.
Less ringing, sort of?
Yeah, exactly. That vibration, chatter, leaves those ugly marks on the surface. Bad finish. The tailstock dampens those vibrations significantly by adding stability.
Okay.
So you get a much smoother finish, maybe a lower raw value, and often better roundness too, which is critical for like aerospace parts or anything high precision.
Right, where tolerances are tight. And you mentioned alignment and concentricity too.
Yes. It helps ensure the workpiece spins true, right on the lathe's center axis along its whole length. Without that end support, even a tiny bit of flex can make it wobble off axis.
Ah, so it keeps everything lined up rotationally.
Pretty much. It combats those errors in roundness or straightness that come from just not having enough support out of the free end.
Okay, the case for using a tailstock on long parts is definitely clear. Now, I hear people talk about live centers and dead centers. What's the difference? One sounds a bit, final.
Yeah, the names are a bit dramatic. It's actually pretty simple. It's all about whether the tip rotates or not.
Okay.
A live center, this is the key part, has bearings inside it. So its pointed tip can actually rotate with the workpiece.
Oh, interesting. So it spins along with the part.
Exactly. And because it spins, there's way less friction right at that contact point. Less friction means less heat.
I see. Less heat buildup.
Right, which is a big deal, especially the higher speeds you run on a CNC.
Okay, so that's live. What about dead?
A dead center is just a solid piece of hardened steel. It doesn't rotate. The workpiece spins against its stationary tip.
Ah, okay. So workpiece rubs against the tip.
You got it. And as you can guess, that creates a lot more friction
Yeah,
and definitely more heat.
right. Makes sense. So when do you use which? Is one better?
Well, for most modern CNC turning, especially if you're pushing for speed and efficiency, the live center is generally what you want.
Why is that? The heat thing.
Yeah, mainly. Because it rotates, you avoid overheating and potentially distorting or burning the center hole you drilled to your part. Plus, it lets you run at those higher RPMs without trouble.
So live centers for speed and CNC work.
Pretty much the standard choice now, yeah. Dead
Right.
centers. They're simpler, sure. And they can be very rigid initially. But that friction means lower speed limits, and you have to keep them lubricated, otherwise the tip wears down fast, or you get excessive heat. Not ideal for long, automated CNC runs, where you want things to just run.
Right, you don't want to be stopping to add grease all the time.
Exactly. So you see dead centers more on like manual lathes, simpler jobs, or maybe very specific low-speed, high-rigidity setups.
Got it. Live for CNC speed, dead for simpler or slower stuff. Okay, but let's say you are using a tailstock, maybe even a live center, but you're still getting taper or other issues. What gives then?
Ah, good question. That often points to one of two culprits. Either the tailstock isn't properly aligned with the spindle, or you're using the wrong amount of pressure.
Wait, misalignment can cause the problem it's supposed to fix.
Absolutely. If that tailstock isn't pointing perfectly straight at the center of the spindle, it's actually forcing the workpiece to spin slightly. Crooked, eccentrically.
Wheels out of alignment on a car, it pulls weird.
Exactly like that. If it's offset horizontally or maybe vertically too high or too low, the part isn't rotating on a true axis, and that will cause taper. Guaranteed. It can mess up roundness too.
Wow. Okay, so alignment is absolutely crucial, non-negotiable.
Totally. Precise alignment means concentric rotation. That's the foundation for accurate turning.
Okay, alignment is one thing. What about pressure? You said too much or too little?
Yeah, finding the sweet spot for pressure from the quill, that's the part that extends out, is key. Too little pressure.
What happens then?
The workpiece isn't held securely enough. It can vibrate more chatter again, or even shift slightly under the cutting force. Maybe deflect a bit. Result, bad finish, dimensions drift, maybe even shorter tool life because the cut isn't stable.
So not enough grip, basically, leads to instability. What if you crank it down too hard? Too much pressure?
Also bad news,
Uh-huh.
especially on slender parts. You can actually bend or bow the workpiece.
Seriously? Bow the metal?
Yep. Or you could damage that little center drilled hole where the center fits. If you're using a dead center, too much pressure means way too much heat and wear.
Mm-hmm.
And even with a live center, excessive pressure puts extra load on its internal bearings, wearing them out faster. It can even put stress back onto the main spindle bearings of the machine.
Okay, so it's a real balancing act. Enough pressure to hold firm, but not so much you deform the part or damage something.
Exactly. You need both. That perfect geometric alignment and the right amount of clamping force for that specific job.
This is all super important, but how do you actually do it? How do you adjust the tailstock properly? You can't just eyeball that kind of precision, right? Especially on a CNC.
No way. Guesswork here is just asking for trouble, asking for scrap parts. There's a definite procedure, a systematic way to get it right.
Okay, walk us through it. What are the steps?
All right. First, you need to find the main lock, the clamp that holds the whole tailstock body onto the lathe bedways. Loosen that up.
Loosen the main lock. Got it.
Then you physically slide the whole tailstock along the ways until it's roughly in the right position for the length of your part.
Okay, rough position.
Then lock it down again. Tighten that main lock so the body is secure.
Locked in place. Next.
Next, you use the hand wheel or the lead screw on the tailstock itself to extend the quill that's the moving cylinder part. Put your center, lever dead, into the quill's taper.
Extend quill, install the center.
Mm.
Okay. Now the tricky part. Alignment.
Now, the alignment check. This is where the precision happens. You'll need something accurate to measure against. Usually a precision ground test bar mounted between the chuck and the tailstock center.
Or
You could carefully turn a precise diameter on a piece of stock held only in the chuck, near where the tailstock will be.
okay, got a reference surface. Then what?
Then you get a sensitive dial test indicator. Mounted on the tool post or carriage, somewhere it can reach that test bar or turn diameter.
Right, the indicator. What are you measuring?
Two things, vertical alignment and horizontal alignment. For vertical, you run the indicator tip along the top of the test bar or your turned surface.
Uh-huh.
If the needle moves as you traverse along, the tailstock is either too high or too low relative to the spindle centerline.
And how do you fix that?
Often, you have to use shims, thin metal plates placed under the tailstock base to raise it just the right amount until the indicator reads 0 all the way across the top.
Shims for vertical. Okay, what about side to side, the horizontal?
Same idea, but you run the indicator along the side of the test bar, the side facing you.
Okay.
If the reading changes there, it's off horizontally. Most tailstocks have some kind of side set screws, little adjustment screws, that let you nudge the tailstock body slightly left or right.
Ah, fine adjustment screws.
Yep, you tweak those screws until the indicator reads 0 all along the side as well.
So indicator on top, adjust height with shims, indicator on the side, adjust with set screws, until it reads 0 in both directions.
You got it. That means it's aligned perfectly with the spindle axis.
Phew. Okay, sounds meticulous. Once it's aligned, what about setting that pressure we talked about?
Right. Now you carefully advance the quill using the hand wheel until the center engages snugly in the center drilled hole in your workpiece.
Snugly. How snug is snug?
Good question. It needs enough force to securely support the part, stop any wiggle or vibration when cutting starts, but not so much force that you risk bending the part or damaging the center hole or bearings.
So it's a bit of a feel thing, or are there numbers?
It can be feel, developed with experience. Some machines or manuals might give recommended pressure ranges, often based on quill diameter or workpiece size. But yeah, often it's careful judgment.
Okay.
And finally, before you hit cycle start, just give the end of the workpiece near the tailstock a gentle push or wiggle. Make sure it feels solid, no play.
Final check for stability.
Yep. And maybe for really long or critical parts, you might even do a quick test cut, measure for any tiny taper that might still be there due to, say, slight wear in the bedways, and make one last micro adjustment if needed.
Wow, okay. That's a really thorough process. Definitely not just slapping it on there.
Absolutely not. It's systematic, takes out the guesswork, ensures you get that stable, accurate support you need for good results.
Man, this has been super insightful. So, quick recap. Tailstock. Absolutely vital for long parts.
Crucial.
Boosts accuracy, improves surface finish by fighting deflection and vibration.
Big cut.
Live centers generally better for CNC due to speed and heat. Dead centers have their place, but maybe less common now.
That's the gist, yeah. Live centers handle the RPMs better.
And the absolute key takeaway seems to be alignment and pressure have to be spot on.
Nail those two, and you're way ahead of the game.
Following that systematic adjustment procedure is the way to get there.
Definitely. Takes a few minutes, saves hours of headaches, and potentially a lot of scrap material.
It really connects back to those initial frustrations, doesn't it? Wobbly parts, bad finish. Understanding the tailstock is a direct path to fixing a lot of that.
It really is. Get the fundamentals right, like proper workpiece support, and so many other problems just disappear.
Makes you think, though, if something seemingly simple like tailstock setup is that sensitive and has such a big impact, what other parts of the whole CNC setup might be hiding similar opportunities? You know, for boosting accuracy or efficiency.
That's a great point. It really does highlight how everything's connected in machining tool holding, programming strategies, machine condition. They all play a part.
So maybe with this solid understanding of the tailstock, what new doors does that open? What kind of challenging parts could someone now tackle with more confidence?
Exactly. Knowing you've got that foundational support right might just give you the confidence to push the boundaries a bit more. Something to chew on.
Definitely something to think about. Well, thanks for breaking all that down. This was a fantastic deep dive.